Brain-to-Brain Interfaces, The Ethics of Thought by Kathleen Mercury. Brain-to-brain interfaces, an emerging technology, present challenges to our sense of self, autonomy, and privacy. Brain-to-brain interfaces are a new area of research in neuroscience where signals from a human brain are passed to animals or human brains using technology to generate a response or action. The ethical implications are significant. What are thoughts? Thoughts about thoughts? Down the rabbit hole. Thoughts. What does it mean to think? Thoughts are ideas, but also is the process of conceptualizing ideas, and your thoughts help you to understand, interpret, and interact meaningfully with the world. Your thoughts are private, only you have access to them. I think, therefore I am. This quote by René Descartes gets at the heart of how we see our thoughts as a key central component to our sense of self and who we are. According to the research team led by Rao in 2013, the development of brain-to-brain technology is limited by our lack of complete understanding of how the neural patterns in our brain of abstract thoughts and cognitive information is encoded. So currently, the use of imaging and measurement of psychological states and thoughts in our brains is very limited, but it is in principle possible. Although it may not be a goal for future research, it's worth discussing from an ethical standpoint. Structures and functions of the brain. The organization of the brain's processing areas is consistent across the human population. The brain has localized function, meaning that each area of the brain has specific functions, and those areas of function are consistent for most humans. But from a research standpoint, we can generalize across humans, but exact locations from one person to another won't be exactly similar. Looking at the pair of the images at the top, you can see the occipital lobe in the back, colored orange. If you look down to the next level, you can see that the occipital lobe is actually the area important for processing vision. So this is consistent across people. Multiple areas of the brain are active during complex tasks, as different areas of the brain contribute to thoughts and actions. Reading, for example, requires many different areas of the brain. You can see what's tagged green. The visual processing of reading is located in the back as described earlier, but you can also see that reading is processed by several different parts of the brain working in conjunction to make sense. Brain scanning and stimulation technology. What tools are used to make BBI possible? One of the most important aspects about brain-to-brain interface research is that it is non-invasive. The human skull and human brain remain untouched by surgical implements. Electroencephalogram measure brain activity, and spikes, according to neural activity occurring in specific areas, can indicate that processing is taking place. Transcranial ultrasound stimulation technology and the related transcranial magnetic resonance stimulation technology use pulses of either ultrasound waves or magnetic waves to access and stimulate different parts of the brain. Again, this technology is considered non-invasive, as surgery does not take place, but some argue here that non-invasive may be a misnomer. How brain-to-brain interfacing works. What is the process by which BBI occurs? The non-invasive brain-to-brain interface device developed by the Rao team combines electroencephalography, EEG, for recording brain signals with transcranial magnetic stimulation, TMS, for delivering information to the brain. A visual motor task must be completed by two humans through direct brain-to-brain communication to achieve a desired goal in a computer game. The brain-to-brain interface detects motor imagery and EEG signals recorded from one object, the sender, and transmits this information over the internet to the motor cortex of a second subject, the receiver. This allows the sender to cause a desired motor response in the receiver, a press on a touchpad via TMS. Let's watch to see the experiment in action.
Yes! Success.
All right. Yes! All right.
The internet means brain to brain interfaces can occur between two or more senders, receivers, or other participants around the world. Possibilities with brain to brain interfaces. Functions. What are the possible configurations with BBI? Extraction and delivery are two different ways that the brain can be used. Extraction to access, record, harvest, or use organic thoughts, and delivery the use of technology to impose thoughts. The direction of information flow can be unidirectional, and that it could be from the user just to a computer or from a computer just to a user. It could be bidirectional, in which information is exchanged between the computer and the user, and of course, users on the other end. It could also be multidirectional, when multiple users' brains are interacting with each other's. Senders and receivers of messages do not need to be connected to the same computer, so this could occur worldwide. Possibilities with brain to brain interfaces, therapeutic. Diminished functionality of the brain could be restored or synthetically replaced with brain to brain interfaces. Mental disorders, neurological disorders, and even just improving social behavior are possible with brain to brain interfaces. Using technology to augment the brain's ability has already been used with success in Parkinson's disease, cochlear implants, sufferers of stroke, tinnitus, even depression. BBI technology could further improve our ability to treat people who suffer from disorders and illnesses. The risks would have to be weighed against the possible benefits, similar to drugs. But, for example, deep brain stimulation for sufferers of Parkinson's disease has led to improvements in Parkinson's disease symptoms, but also has shown an increased risk of suicide and psychiatric disorders. Social behavior could be improved by simply downloading how another person is thinking and feeling, thus eliminating a lot of problems and misunderstandings. Think of the positive and negative benefits that a sufferer of depression could have if they could delete, change, augment, or replace the memories that are causing their suffering. As we consider these possibilities, we can begin to see where the ethical questions of future research loom. Possibilities with brain to brain interfaces enhancement. Normal brain function can be improved or increased with BBI. Embellishment. Our brain's natural capabilities could be enhanced so we can think, act, and live better. What if we could dramatically increase the speed of knowledge or skill acquisition? But would inequity arise as an issue, as the poor couldn't afford the cost of enhancing themselves? Tyranny of the normal. Will we be expected to enhance our natural capabilities? What negative consequences will present themselves if we don't? Will we somehow be forcing new standards of behavior and performance through the use of BBI technology? Will our natural limitations be seen as weakness and something that is wrong and needs to be fixed? Possibilities with brain to brain interfaces, unethical uses. With great power comes great responsibility. Possibilities, unethical use, coercion. Thoughts, actions, or impulses could be implanted or extracted without permission. Surveillance. Thoughts, actions, or impulses could be monitored with or without consent. Could access to our brains be forced upon us? Will we have the ability to refuse? This may be science fiction, or this may be the future. Is lie detection possible? Deception. The implantation of false memories. Will we be forced to use brain to brain interfaces just to keep up with others, even if we are the ones forcing ourselves? Errors in utilization. If the technology doesn't work correctly, the implications and impacts are significant. Technical problems. If the devices malfunction or don't work correctly, the results can be deadly, dangerous, or embarrassing. The wrong information could be extracted, thus leading us to a new field of neurosecurity. Hacking is possible with pacemakers, so what's to stop someone from accessing our brains using this technology? The behavior of others could be controlled. Spies and criminals could use covert communication, and even the DIY community could create this technology themselves. Non-invasive could be a misnomer, as certainly this technology does have an impact on brain tissue, and perhaps that is something that needs to be addressed. Ethical concerns. What are the fundamental ethical questions about using this type of technology? As a reminder, currently it is impossible to access a person's thoughts to record or manipulate them, but research can progress, and it's worth discussing the possibilities, even if they aren't as realistic as we may present here. The three main areas of ethical concerns I would like to address are personhood, or the sense of self, autonomy and our moral agency, and finally, privacy. Personhood. If your thoughts become someone else's thoughts, or other thoughts become your thoughts, how will this change your sense of who you are? BBI technology disrespect the limits of nature? Will we lose what it means to make us human? What is the authentic self? How do we define individuality? Will we develop a new communal sense of identity if unidirectional brain-to-brain interface technology takes place? What will be the union of man and machine? What will be the separation between man and machine? And how will we know the difference? Autonomy and moral agency. When the sender and receiver of a thought or action isn't the same person, who bears responsibility for the consequences? What are the possibilities, implications, and concerns over the loss of our own control? What will happen if we gain the ability to control others? Privacy. The human brain is no longer inviolate. How is our right to privacy affected by the possibilities of brain-to-brain interfaces? What is the balance between the rights of the individual and the society? We may not want to share our fears. Others may not want to know. But with a lack of privacy, how will we be able to filter and comprehend all this information? How will we see ourselves as discrete individuals, authentic in our own thoughts, beliefs, and actions, if those walls between what separate us from others come tumbling down? What is most thought-provoking in these thought-provoking times is that we are still not thinking. Future research. As research continues, what needs to be done to ensure ethical research occurs? Research on brain-to-brain interfaces should continue, but we need to be mindful of the potential risks and remember that these treatments and solutions are just options and certainly not the only solution to our problems. The short-term and long-term impacts on brain tissue itself is unknown at this time, so research should proceed, but cautiously. Legislation is needed to ensure that brain-to-brain interface research is confined to what is morally and ethically responsible. For example, no legislation currently exists regarding informed consent and protecting personal data in brain-to-brain interface research. Protocols need to be developed for research on human subjects in brain-to-brain research. For example, looking at neural grafting studies and how the potential for transfer of individual characteristics are addressed is one way to start. Communication between the scientific community and the public is needed to clarify what BBI is and isn't, learning from the public's reaction to Dolly, the cloned sheep, and genetically modified organisms. Best School of Ethics, Deontology. How does it apply to brain-to-brain interfaces? As a deontologist, the means matter more than the end. We must keep the impact of brain-to-brain interface research on the users as the primary goal, to not harm, to respect their personhood, autonomy, moral agency, and privacy. We cannot use people as guinea pigs for research, so we must proceed cautiously and ensure that every possible safeguard is in place. Usage of brain-to-brain interface technology must include informed consent, with strict guidelines for use to avoid abuse. Finally, as Batty asked Tyrell in Blade Runner, can the maker repair what he makes?